In this example, once again, we rewrite our integral here as the integral from 1 to 0, of 16x minus 2 times 4x squared minus x plus 1, and we replace the square root up here with the power of a half. And we have our dx there. So we follow our procedure. F at x is the larger function. 4x squared minus x plus 1. G at x is the other function or term in the product. 16x minus 2. We get the first derivative of x. So 4x squared, the derivative is 8x. And the derivative of minus x is minus 1. To get the constant a, we divide the coefficient of x here in g at x, which is 16, and we divide that by the equivalent coefficient here of x here, which is 8x. So that'll give us an a value of 16 divided by 8, which gives us 2. So the question is a times the first derivative of f prime x equal to g at x? So multiply it out here. A is 2 times 8x minus 1. That gives us 16x minus 2. And that, in fact, is equal to g at x. So yes, the answer is yes. And once we have a yes there, that means we can use our rule here. And our rule says that the integral of a times f prime x, fx to the power of n dx, is equal to a times the function brought to the power of n plus 1. So we raise the power by 1 and we divide by that raised power. So that's our rule again. And now we're going to apply that rule to this example here. So we're going from, is it 1 to 0? Just check my limits here. We're going from plus 1 to 0. And it is a, which is 2 times 8x minus 1. And then our function is 4x squared minus x plus 1. And that is to the power of a half dx. So that's our original function. And then when we integrate that, we get 2 times. And it is 4x squared minus x plus 1. And it was a half, so a half plus 1 is a half plus 2 over 2, which is 3 over 2. So our new power, our raised power is 3 over 2, and we divide by our raised power, which is 3 over 2. And here we're going from our limits of 1 to 0. And I go back here. So if I continue on then, I can, first of all, that gives me 2 times 2 over 3, because I invert the 3 over 2. So 1 over 3 over 2 is the same as multiplying by 2 over 3. And in this case here, I'm going to split this here into 4x squared minus x plus 1. And that's times 3 to the power of a half, going from 1 to 0. And that gives me 4/3 times the square root, because it's to the power of a half. So it's 4x squared minus x plus 1, all to be cubed. And then it's the square root of all that. And we know it's the square root because we have a half here. And that's going from 1 to 0. So if I just scroll down here and continue on, that gives me 4/3 times the root of, and I'll just write the 4, the minus, and the plus 1. That's all to be cubed, minus, open up the square root again, 4 And sorry, if I can do it in one go here. If I just have my colors, so that's 4 times 1 squared minus 1 plus 1 cubed. And here I'm putting in 0 squared minus 0 plus 1, and all of that to be cubed. So we put in the upper and lower limits. The next step then is to evaluate it on the next line. So it's 4/3 times the square root, and on this side I have 4 minus 1 plus 1, so it's basically 4 cubed. If I just shorten this down, square root down a bit, 4 to the power of 3 minus, and this one is 4 times 0 goes to 0, that goes to 0, and I'm just left with 1, the square root of 1 cubed, which is going to be 1. So if I keep going with this, it's 4/3 times, now 4 cubed, 4 fours is 16, 4 16s are 64. So it's the square root of 64 minus the square root of 1 cubed, which is 1. And that gives me, if I scroll down a little bit, that gives me 4/3 times, of course, the square root of 64 is 8 minus 1. So that gives me 7, 4 sevens, 4/3 times 7. So it's basically 4 sevens, 28 over 3, which is 9 1/3, so it's 9.33. 3 nines are 27, and you're left with 1/3. So our answer there is 9.33.